Okay, now we will start our presentation.
Assalamualaikum and a very good night to everyone. We are second year student from UTM will present you about the topic concrete strength and mixed proportion. So let me introduce you to myself and my member. Next. So my name is Siti Nurlina binti Moha and my friends Nurul Shahira binti Zainal and Nurul Ashikin binti Kamarul Zaman. And there are four gentlemen in this member who are Tan Di Yao, Li Yihao, Lo Yan Fung, and Le Ki Hong. Next. So the objective of our presentation is to identify the different type of concrete strength, to know the different method to determine the concrete mix proportion, and to know the designing concrete mix using DOE method. This method is used in Malaysia. And next, we are going to go through to an example calculation of concrete mix design. Next. So as you can see in the figure below, you can see there's different type of elements, C25, C35, C50, and C16. These show the different concrete strength. As you can see, the elements that are used are different amount, depend on the concrete strength. As the concrete strength increase, the cement use increase, while the free water cement ratio decrease. Next. So there are three types of force that occur in concrete, which is compression, tension, and shear stress. So for hardened concrete, we need to ensure that it have enough compressive strength to withstand the load that occur on it. As we know that concrete have good compressive strength but not in tensile strength. That are why we usually use steel bar in the concrete reinforcement to ensure that it have enough strength. Next. So there are three types of tests that we are going to do for the concrete strength, which is the sample is whether in cube or cylinder. The test that we'll conduct to know the concrete strength is characteristic strength, crushing compressive strength, and average compressing strength, which use three samples. Next. Next, I will continue with my friend Shahira.
Thank you, Lina. So, I will continue the presentation. Characteristic strength FCU is a strength in which not more than 5% of the cube has crushing strength lower than specified strength. So, let us look at the figure. What it means is, when we plot the graph, the characteristic strength is mean strength in the middle part minus with 1.64 S. S is the standard deviation of sample strength. So here we get the FCU, which is 30. Only 5% of the sample has crushing strength lower than the specified value. Next. The concrete grade. Concrete grade defined as a minimum compressive strength of concrete. It must possess after 28 days of construction. For example, concrete with grade 45, or we call M45, has a minimum compressive strength or characteristic strength of 45 MPa at 28 days. M stands for mix, while the number at the back stands for the compressive strength. Next. Cube or cylinder crushing strength is the ultimate compressive strength of concrete at failure. So, we test the concrete cube or cylinder sample until it failed. Then we obtain the crushing strength. Next. This is the typical mode of failure of the test. So, for cube sample, we have non-explosive and explosive. And for cylinder sample, we have splitting, shear, and last one, splitting and shear. Next. So, what is this? Okay, this is also a concrete grade, but this one we compare both tube and cylinder strength of the concrete. So the first is the characteristic strength of a standard concrete cylinder, and the latter is the characteristic strength of a standard concrete tube. So the strength for cylinder over strength of tube must approximately equal to 0.8. Okay, next I will pass to Ashikin.
Oh, okay. Thank you, Shahira. The things that have to be noted is that why concrete mixed proportion needs to be designed. This is because it is the process of determining the relative proportions of concrete constituents to produce workable and an economical concrete to achieve the required strength and durability. What next steps has to be done after design mix process, which is after completing the design mix process, the trial mix and concrete testing have to be conducted to make sure no failure during construction. The objectives of mixed design: satisfying the requirements of fresh concrete, which is workability, satisfying the properties of hardened concrete, strength and durability, most economical for the desired specifications and given materials at a given site, performing most optimally in the given structure under given conditions of environment. Now I'll pass to the Ashkin.
Okay. Okay, now I will give the presentation about the nominal mix and also the design mix. Okay, nominal mix is the proportions are prescribed in the standard specifications, and nominal mix is adopted for ordinary concrete, and it is preferred for simpler, relatively unimportant, and also small concrete works. On the other hand, design mix is the proportions are properly determined with their relatively ratio to achieve desired strength, and the properties of the fresh concrete like workability or performance of concrete are also taken in detailed consideration. Okay, next. Okay, next I will give the about the advantages or and the disadvantages of nominal mix. Okay, the advantages is that the prescriptive type of concrete because proportion is pre-decided, and then it is also easy to make at the construction site. And there's no need to have any skill for the person to make the nominal mix concrete. And for the disadvantages of nominal mix need to be based on the experience and past of the empirical studies. And while doing this nominal mix, we may not create the exactly designed strength. And the water cement ratio is considered by assumption, which may lead to bleeding and segregation of concrete. Okay, next. uh, Nominal mix is according to the proportion weight of the material or by volume using the ratio. Okay, there's two ratio used in nominal mix which are 1:4 or 1:1.5 and 3. Okay, the order of the ratio is cement, fine aggregate and coarse aggregate. Okay, the ratio 1:4 is used for the compressive strength that is less than 30 or less than 25 MPa. Okay, and then we need to specify the water cement ratio and consider the size of the coarse aggregate. And then the surrounding environment does not affect the nominal mix. And by using the value of the concrete wet density, the value of nominal mix ratio, and the water cement ratio, we can calculate the amount of concrete constituents, such as the amount of cement, the amount of fine aggregate, the amount of coarse aggregate, and also water. Okay, next I will pass to Tan. Mm, okay, mana?
And
Okay.
it is a defined list of concrete within British Standard 5328, which are made with a prescribed quantity of materials as required in the British Standard. These concretes are normally mixed on site or small-scale jobs or obtained from a supplier with no quantity standards. Standard prescribed concretes are fairly basic mixes and have no strength guarantee, although this can be assumed based on the values obtained from the British Standard 8500. And for your information, British Standard 8500 is the newer version of British Standard 5328. The client specified its grade of concrete, workability, and size of course. The supplier needs to determine the actual mix proportions by trial and error to determine the water cement ratio. Next. Next. Next slide. Okay, for the design process, first, we need specific aggregate. Next slide. So, from the table, coarse aggregate can be 20 mm or 40 mm maximum size. And there are 4 slump classes, which are from S1 to S4. Then, we determine the strength required standard mix from ST1 to ST5. Read across the table to identify the required cement content, the total aggregate content, and the proportions of the aggregate, which should be a particular grade of fine aggregate. Back to the previous slide. So, it is important to note that all material must be accurately weight spacer. When batching by weight, the cement contents may be reduced by 10% if the standard strength class of the cement is greater than 32.5, for example 42.5 or higher. Next, coarse, fine and all-in aggregate must comply with British Standard 12620. All-in aggregate. Next. So this is the category mix and users. For ST1, which is also known as wet lean mixed concrete, the strength is assumed to be 7.5 Newton per millimeter square at 28 days. And the applications are as stated below, which is curb bedding, backing, drainage work, honging, and blinding. Next, for ST2, it is extremely versatile mixed concrete. The strength is also assumed to be 10 Newton per millimeter square at 28 days. The applications are unreinforced strip footings, drainage works, blinding horse floors, and pad foundations. Thirdly, for ST3, it is used for domestic applications, but no wearing surface to 15 Newton per millimeter square at 28 days. In shed and workshop bases, foundations for large walls, garage, house extensions, and also unreinforced bases. For ST4, it is used for agriculture and industrial applications, and it is suitable as a wearing surface for light foot traffic. The strength is assumed to be 20 Newton per millimeter square and 38 days. The applications are garage floors, shed and workshop bases, and drain and channel bedding. Lastly, for ST5, it is used for domestic, commercial, and agricultural applications, and also it is suitable for light, foot, and trolley traffic only. The strength is assumed to be 25 Newton per millimeter square and 28 days. The applications include agricultural equipment stores, foundations for traffic signposts, foundation for environmental barrier posts, lighting columns, the house and garage ground floor slabs. Next.
Okay, thank you, Dayao. The design mix is designing the correct proportion of ingredients, which are the cement, fine, and coarse aggregate, and water to produce the concrete that having the specified properties. These properties are usually the workability of the fresh concrete, the compressive strength, and the durability.
The required properties of fresh concrete are governed by the methods of placing and transporting. For example, if the method of placing is pumping, for sure the concrete requires higher workability, while the properties of hardened concrete are specified by the designer of structure, and design mix is usually used for important and major projects. Why? Because when a large volume of concrete is required for construction, a minimization of the cement usage could save the cost on the construction by designing an economical concrete while maintaining the strength and durability required. Next. So most of the verbal mix design methods are based on the empirical relationship, chart, and graph developed from extensive experimental investigation. And here are some common used mix design methods. And today we will explain about the DOE mix design method. Next. There are 5 steps in the DOE mix design method, which are the first step is to determine the free water cement ratio and is based on the strength required for the concrete mix. And next, we will determine the free water content based on the workability required. After finding the free water cement ratio and free water content, we can determine the cement content. And then we will determine the total aggregate content. And last, we will determine the fine and coarse aggregate content. Next. The first step to determine the free water content, free water cement ratio, we need to determine the target mean strength, where the target mean strength is equal to the specified characteristic strength plus the margin, where the margin is K multiplied with S, where the K is a value appropriate to the percentage defective permitted below the characteristic strength. For example, if the defective percentage is 5%, then the K value will be 1.64. And S is the standard deviation which can be obtained from the first graph, where there is 2 lines, line A and line B. If previous information concerning the variability of strength test is less than 20 result, the standard deviation should obtain from line A, while previous information more than 20 result, the standard deviation is obtained from line B. Next, we will go to the table 2. We will estimate the compressive strength for the free water cement ratio of 0.5. After finding the compressive strength, we will plot a graph which is the parallel to the printed graph, which is green color line, until it intercepts a horizontal line which intercept with the blue color line through the ordinate representing the target mean strength. Then from here we can determine the free water cement ratio. Next. Is to determine the free water content. We can estimate the free water content from the workability and the maximum size of aggregate. If the coarse and fine aggregate of different types are used, the free water content is estimated by the expression where 2/3 from the free water content of fine aggregate and 1/3 from the free water content of coarse aggregate. Next. After finding the free water cement ratio and free water content, we can determine the cement content, where the cement content is divide the free water content with free water cement ratio. Next. To determine the total aggregate content, it requires an estimate of the density of the fully compacted concrete depending on the free water content and the relative density of the combined aggregate in the saturated surface dry condition. If no information is available regarding the density of aggregate, an approximation can be made by assuming a value of 2.6 for uncrushed aggregate and 2.7 for crushed aggregate. From this estimated density of concrete, the total aggregate content is determined from calculation, where the total aggregate content is equal to the wet density of concrete, subtract with the cement content and free water content. Next. To determine the fine and coarse aggregate content, we need to find the proportion of fine aggregate, which is depending on the maximum size of aggregate, the workability level, grading of fine aggregate, which usually defined by its percentage passing 600 micrometer sheet, the free water cement ratio. After finding the proportion of fine aggregate, we can determine the fine aggregate content and coarse aggregate content, where the fine aggregate content is equal to the total aggregate content multiplied with the proportion of fines, while coarse aggregate content is equal to the total aggregate content minus with fine aggregate content. And next, I would like to invite Yan Peng to explain about the calculation example by using DOE method. Thank you.
Okay, thank you, Lee. Now we will proceed to the examples of DOE calculation, design concrete mix proportions. The following criteria are characteristic strength equal to 25 Newton per millimeter square, type of cement, ordinary Portland cement, slump required 100 millimeter. The slump required is 100 millimeter because this is to produce workable concrete, and also 100 millimeter slump is very common with normal weight concrete, which is good for pumping. Slumps that are above average will cause reduced strength, durability, and permeability of the concrete. A mixture should be used instead of water to achieve higher slumps so that you can maintain the quality of your concrete. The type of size of coarse aggregate is crushed granite, which is 20 millimeter. Type of fine aggregate is crushed. Relative density of aggregate is 2.65. Percentage defective rate 5%, which is K equal to 1.64. Percentage fine aggregate passing 600 micrometer sieve equal to 45%. The 45% has been chosen. This is because fine aggregate can fill up the void between coarse aggregate, making denser, which is within the acceptable range. A fine aggregate deficiency will result in a mixture that is harsh, prone to segregation, and difficult to finish the number. An excess of fine aggregate will lead to some extent more permeable and less economical concrete, even if it is low workability. More cementitious material is needed when final aggregate gradings are used. Now, I would like to invite the Le Gihong to present about the graph.
Okay, so for us to perform the DOE method, we have to use this form for mixed design. So as given in the questions, we know that the characteristic strength is 25 Newton per millimeter square at 28 days, and the given proportion defective is 5%. So we have to find the standard deviation now. Next. So in this case, we use line A since there is no previous data given. So our characteristic strength is 25. We draw a vertical line from 25 until it touch 8. And we know that our standard deviation is 8. Next. Our K is 1.64 since our proportion defective is 5%. So 1.64 times 8 equal to 13. Our target mean strength will be characteristic strength plus 13 equal to 38. So our cement strength class is 42.5 since our cement used is ordinary Portland cement. Our cost and fine aggregate type is crushed. Now we have to find the free water cement ratio. Next. So in order to find the free water cement ratio, we have to approximate the compressive strength first for free water cement ratio equal to 0.5. As given, the cement strength class equal to 42.5, crushed aggregate, and the edge of concrete is 28 days. So we get our approximate compressive strength equal to 49. Next. We have to plot the graph with the free water cement ratio equal to 0.5, the compressive strength from the table, which is 49. So we have to plot the graph. Since there is no curve past the point, so we have to draw a new curve by following the shape of the other curve as our reference. So in this case, in order for us to find the free water cement ratio, our compressive strength is 38. Our target compressive strength is 38. So we draw a horizontal line until it reaches the curve, and we get our free water cement ratio equal to 0.58. Next. Yes, as given. Next. Our slump given is 100 millimeter, and our maximum aggregate size given is 20 millimeter. In this case, we have to find our free water content. Next. In order to find our free water content, we have to use table 3, which our maximum aggregate size is 20 millimeter. Our type of aggregate is crushed, and our slump is 100 millimeter. So we can get our free water content equal to 225 kg per meter cube. Next. So as we know previous slide. So as you know that the water cement ratio equal to water content divided by cement content. So we can use that equation to find our cement content, which is 388 kilogram per meter cube. Next. For Stage 4, our given relative density of aggregate SSD is 2.65. We can use this to find our concrete density or wet density. Next. So we have to draw a new line again since there is no line labeled as 2.65. So we draw a line labeled as 2.65 and our free water cement contains 225. So we can get our wet density equal to 2,350. Next. As we know that the wet density equal to total aggregate plus cement content plus water content. So we can calculate the total aggregate content equal to 1,737 kilogram per meter cube. So as given, our percentage passing 600 micrometer thick is 45%. So we can use this to estimate our proportion of fine aggregate from a graph. Next. So in this case, since our slump is 100 millimeter, so we use the section 4. Our percentage of passing 600 micrometers thick is 45. Since there is no 45, so we have to draw a new line between the 40 and 60 as shown. Next. Our free water cement ratio is 0.58, so we draw a vertical line until it reaches the 45%, and we can get that the proportion of fine aggregate is equal to 44%. Next. So we can get the fine aggregate content equal to the total aggregate content times 44%. So we can get 764.28 kilogram per meter cube, and the remaining will be coarse aggregate. Next. That's all from us. Any questions?
Now we have found one question, which is if the targeted strength is 53 Newton per millimeter cube, but after the concrete testing is 46 Newton per meter cube, the requirement is 40 Newton per millimeter cube. Does the concrete can be used? So I would say the concrete can be used because although the compressive strength from the testing is 46 Newton per millimeter cube, which is not achieving the targeted strength, 53 Newton per millimeter cube, since the requirement is 40 Newton per millimeter cube, as long as it passes the requirement, so the concrete can be used. Next question to have.
So next question is from Mariam, which is, what is the difference between FCU, FC, and FCK? As you can see from the slide before, there is FCU is characteristic strength for cube, which is CUBE, cube, FCU, and FC is for cylinder, characteristic strength for cylinder, and FCK is like for common, like they are not specified whether the sample is cube or cylinder, then we will use FCK. Is it answering your question, Mariam? Bagus. Any question from the viewers?
So if there is no questions, can we have a photo session? Yes. Can show your face from the camera.
Okay, you want to camera? You want to take photo? Is there any question? No more question, right? If no, then open your camera. Wow, so handsome, everyone. Especially Muhammad Imran. Wow, so pretty woman, Nur Hazana. C1 Yin, don't you want to open your camera? Dua Mukri, don't want to open your camera? Ahmed Ikhwan, is it okay? Alamak, loading ah. Okay, sini kau tolong screenshot ke? Okay, I will count and everyone will say cheese or anything. 1, 2, 3. And another one. 1, 2, smart. All right, thank you everyone for joining us.
Thank you,
Hope you will
everyone.
gain something from our talk.
Thank you, everyone.
Very interesting
Thank you, everyone.
presentation.
Thank you, Pago people.
Thank you, Doktor.
Terbaik.
Good job. Bye.
Sorry.
Bye.
Thank you.
Good job.